How's it going, everybody? In this video, I wanted to cover a technology that's been around for a while, and one that I consider probably one of my more favorite options for inter-AS VPN, and that is going to be option C. Now, the option C is kind of a unique variable. It's kind of like what we talked about in carrier supporting carrier, but it's a little bit different as well. So in carrier supporting carrier, we had three different autonomous systems, or we had two different autonomous systems. We had two geographically different locations for the same service provider, and then another service provider that was providing connectivity for the geographically different SP. In carrier supporting carrier, that is the design to jump across whatever the geographical break is. So again, Orlando to Milwaukee, where you're trying to form a VPNv4 peerings between the route reflectors, but they're in the same autonomous system. So route reflection will work. And so if in this particular case, route reflection between the autonomous systems will not. And you might say, well, how come? Well, for those of you that are familiar with BGP will already know this. And it doesn't matter what the address family you're using. Route reflection is an internal BGP or iBGP only capability. So if I wanted to run route reflection, I can only run that inside of the same AS. So I can configure multiple routers to be a route reflector and have multiple provider edge routers peer with a route reflector and be, handle it from there, which is normally what I do. I normally don't configure full mesh. I will configure the route reflector first with its, however many BGP peerings I need to, and then configure the provider edge routers accordingly to talk back to the route reflector. In option C, you're doing something similar to carrier supporting carrier. You are forming a VPNv4 eBGP peering between the route reflectors, and you're doing that only after having propagated routes. So basically, the idea with inter-AS option C is you're doing what they call a MultiHop eBGP VPNv4 peering. So what that means is, from a logical progression step, and in the description below there will be a link to my blog that I've already covered this. R5 and R6, as well as, where is it? Right there. As well as XR6 and R6 have formed eBGP peerings, a single eBGP peering inside of the IPv4 unicast address family. Now, on the R5 to R6 eBGP peering, I enabled MPLS labeling, so send label, so BGP labels are allocated. And on XR6, I leverage the labeled unicast address family. And once that's up, any routes that either side propagate to the other are then labeled. Additionally, I go ahead and on the provider edge routers, I advertise the loopbacks and the loopbacks of the provider edge routers, as well as the route reflector. And I do that on R5 and XR6 to R6 and R6 for XR3 and the provider edge routers in AS2. And then I redistribute the BGP learned routes into IGP. So there's that way of doing things. So that's a simple way of doing it. To me, it's there are other ways, but that is just the direction for at least the initial running through it scenario that I decided to test out. It's the most common thing I've seen in production. Not to say that it's the only one that I've seen. I've seen BGP labeling as well, where you're using BGP labels to allocate labels. Or should say BGP to do the label allocation. So Once that's been accomplished, so once you have R1 and R8 loopbacks advertised as a network command on R5 and XR6, and R6 learns them and then redistributes those into IGP, and XR3 and R11 can learn them, then the bulk of your work is done. Because the idea is you are going to be propagating internal routes to the other service provider. What will end up happening then is it's assumed that the route reflectors will be able to follow a labeled path and a trace route. Now, I don't really care which direction the trace route takes. I just want to make sure that on every hop to on the path to the remote route reflector, that it's a labeled path. Once that happens, then the VPNv4 peering can happen. So you go underneath the address family VPNv4, and then you activate that adjacency. You also set up as an eBGP MultiHop setup, and I usually just throw the command in there. It defaults to 255 hops, so a maximum TTL, and away you go. Now you don't have to set it to a maximum TTL. You can use whatever variable you want, as long as it's enough to get so the TTL doesn't expire in transit. Now that will get you reachability from between the route reflectors. What that won't do, and this is where option C becomes a little interesting to work with, is if I did a trace route from R1 to R4, or I should say R1 to R11, you would see two label switch paths. The first one would be R1 to XR3, which is the route reflector, because that's going to be the end of the label switch path between the autonomous systems, and then another one from XR3 to R11. Because when you form the VPNv4 peerings between the route reflectors, you are essentially creating on R8, when he learns the updates from XR3, what will end up happening is R8 will pass those down to R1. R1 will receive those and send the traffic out towards the remote end, or the remote AS, in order to forward the traffic. The problem being, though, is XR3 is whichever devices you are forming your peerings off of, that is going to be the end of your label switch path. So your BGP next hop is going to be whatever you're terminating on. So in the case of R8 to XR3, they are their own next hops. So R8's next hop is XR3, XR3's next hop is R8. So regardless of which way you flow, R2 to R4 or R4 to R2, you're going to have a two label switch path. Now, you don't technically have to just use as long as you've advertised the PE loopbacks in there, you could form a VPNv4 peering between the provider edge routers. That is supported, and that would eliminate that, and that would form a single label switch path end to end, because R1 and R11 would point to each other. They would also be the logical and physical end of the path between the ASs. Now, the drawback to that design is, well, scalability. If you've got thousands of provider edge routers, I doubt that you're going to want to spin up thousands of VPNv4 peerings. So there is a way around that, and that is with the next Hop Unchanged command on both iOS and XR. That's done underneath the address family, or underneath the neighbor configuration for the VPNv4 address family. What you're doing is you are instructing VPNv4 to not update, or to not update the next hop to be itself. Meaning that R8 and XR3 should not point themselves in BGP updates to the remote end as the next hop value to reach the destination. So what that means in layman's terms is R1 will no longer see XR3 as its next hop value to get to the remote AS. It will say, you know what, R11 formed a VPNv4 peering with XR3. XR3 then formed a VPNv4 peering with R8, and R8 formed a VPNv4 peering with R1. So what ends up happening is router 1 will then see, after BGP reconvergence happens, which takes about a minute. A minute in my lab, it might take longer in yours or in the real world. But R1 then sees R11 as the router that advertises the routes that R4 advertised to R11. So R11 is your next hop. So that if that's your next hop, as long as you have a route to get there in your routing table, then you have an end-to-end label switch path. And that's what your goal is to have an end-to-end label switch path. If you have a situation where your label switch path is terminating one or two hops or multiple hops before the provider edge router, you're going to have two LSPs. Now that is an inherent problem with option C. So you do the next hop unchanged and that problem goes away. Now with option A, you don't have that problem because you're doing label switch path to the ASBR, and then you're doing a non-labeled path between, because you're in the VRF at that point, so it's labeled native IP labeled path. So R1, if this was option A, it would be R1 to R5 as a labeled path, R5 to R6 via IP, and then R6 to R11 as a labeled path. Obviously, it would be a labeled path from R1 to R7. The channel 4 label would get popped because R7 is directly connected to R5, who is the PE router. So PHP would signal an implicit null to R7, pop the transport label, and then you would see the VPNv4 label, or the VPN label going down to R5. That would get popped as it went from R5 to R6. R6 to R10 would have a 2-label stack, but then once it gets to R10, with it being directly connected to R11, you would see the top label get popped with the implicit null signaling, and then you would see the VPNv4 label sent down to R11. Now with option B would be 3 label switch paths, because instead of you doing per VRF peerings like you do in option A, you're doing a single global BGP peering, adding a label. But the problem being is R1 to R5 would be a label path, R5 to R6 would be a label path, and then R6 to R11 would be a label path. So you have 3 LSPs in option B. Option C is designed to get around that multi-label path design and get you an end-to-end LSP where you form a peering between the route reflectors, and then you simply tell the route reflectors in the VPNv4 capabilities exchange to not modify the update or the next hop update. So instead of XR3 being the next hop, or R8 or R1 or whoever, you point it to the router that advertised the route reflector of the route. So if R11 learned the route from R4, he would go ahead and point himself as the next hop, and that is the goal. So when you get through the there's a lot of little variations of it, and I don't know about you all, but I found the inter-AS option, trying to correlate option A with a given set of requirements or specific capabilities, it took a little while to learn them. And then there's another one that's not quite as well known, and I believe this is Cisco proprietary, which is what they refer to as option AB, or option D, depending on how you want to look at it, which is a combination of option A and B, where you mix the VRFs together, but you form a global IPv4 unicast BGP peering between the PE routers or the ASBRs. I actually haven't demoed that yet. That's going to be one of the next ones that I do. But I want to go through A, B, C, and D. In the order the videos are released and the blog posts are released, it's actually going to be A, B, C, D in that order. But I just happened to, I did C before all of them because the fact that it was as close to a carrier supporting carrier as I could get without having to rebuild. Now the topology also changed. I'm sure you've noticed that by now because we're 15 minutes in. And the reason I did that is because the fact that I want to be able to test both intra-AS and inter-AS options. And eventually I plan on going through and taking this a step further, but this is basically the topology. And the idea here is to be able to test both layer 2 VPN, layer 3 VPN. That's why you see the additional an additional line drawn between the PE routers and the PE or the customer device, and that is there for layer 2 VPN purposes. So I plan on testing out layer 2 VPN as soon as I'm done with all the layer 3 VPN stuff, which I'm almost there. I'm not going to bother doing a bunch of videos on the intra-AS layer 3 VPN because one, I've already done that you could probably look through my YouTube channel and find probably 5 or 6 videos easy on just intra-AS VPN. I've done it so many times that to me there's a couple of specific use cases that I have to test out that are specific to intra-AS, but those are going to be more workbook and video series geared videos and content. But working for a service provider, I play with this stuff pretty regularly. So intra-AS VPN stuff is it really isn't that complicated. It's the inter-AS stuff that I want to be able to configure without even thinking about it. Option A is pretty much a no-brainer because of the fact that it's no different than intra-AS VPN, except for you're doing your VRF config for BGP or whatever routing protocol you use between the providers is just in a different AS. So for those of you that are not familiar with inter-AS options, the back-to-back VRF or option A is probably the probably the easiest transition from intra-area or intra-AS to inter-AS VPN, because you're only doing what you've already done with the customers, except for it's not a customer you're peering with, it's a provider. And if you're doing BGP, there's really nothing to it. If you're using an IGP between them, then there's a little bit more to it. There's other options as well that you could use inside of each major option. Option B is kind of cool too, but it's supposed to be more scalable than option A, but you lose a few capabilities, like your end-to-end label switch path is I shouldn't say you lose capabilities. They all have their own pros and cons. It really depends on what you want to accomplish and what the provider is going to do to peer with you. But that's pretty much it. Not a whole lot of demoing here in this video. I will verify the LSP's work and stuff like that, but I do plan on doing like a VPLS and an HPPLS and then a PBB eBPN video in the near future. The actual physical devices might change slightly from now, but so yeah, that's pretty much it. Just to show you what I mean here, we'll go ahead and on R1 we'll do a show BGP VPNv4 unicast all summary, and we're going to have a bunch of routes from R8. So if we come in here, so we've learned some routes in here. If I expand out on 4, which was learned from, you'll see the next hop is router 11, right? But if I take this route and I take this like so and hit the enter key, you can see that the next hop, it was advertised to us from router 8, but its next hop value is R11. So I do a trace route from 192 trace route to 192.0.2.11, sourcing from loopback 0 numerically. I should have a single label stack, and I do. Well, in this case here, it's not a fair example because of the fact that it's only the transport label. But if I go to R2 and I do the trace route, I only have one VPN label, 57, 57, 57, 57, 57. So when I go ahead and do the trace route, I take the path. I have 57, but I go through R5 and R6 to get to R10, and it drops out to R11. If I had not fixed the next hop information, when it got to 106.10, it would jump to 103.13, because it would have had to go through the route reflector, then back to 103.10, then it would have jumped down to 110.11, and then eventually out to the edge, and would have got to where it's got to go. This way here, I'm bypassing the route reflector altogether. I did that on purpose with the trace routes, just to show, I mean, if we look right here, here we are, right here. So here we're going through the route reflector. So we hit router 10, then we hit XR3, then we hit R10 again, and then we hit R11, and then we hit R14. So and that's a 9 hop LSP. If we come down here, and you'll notice that the label switch path changes. So we get 2014. You'll notice that this is the VPN label, because we're pointing a VPN label towards the provider or the route reflector, and not the actual PE router. You don't actually get the actual LSP until you get to router 10, which picks it up, and then it pops the label anyway. Here we're taking 57 all the way because R11 is our true destination, and that's one of the reasons why it's I like option C, because it's an end-to-end label switch path. But we'll talk about some of the other options as we go along down the road later on. But that's pretty much the way it sits. So beyond that, that's pretty much it. The configurations that I have, you'll see in the blog, in the description in the blog, are directly from these devices here. That's, I usually I'll get it working, I'll blog about it. The blog will be ready to go when the video goes live, and then by the time you watch this video, A, B, C, and D will be done. I won't release them until those 4 videos are ready to go, and then I'll be able to go ahead and release the videos from there, and that'll cover all of layer 3 VPN, and then I'll be able to jump in directly into layer 2 VPN, and that one's going to be a couple of just basic point-to-point, and then the rest of it's going to be like your HVPLS, PBB, EVPN, things like that, just so that they're redocumented. I'm not going to go through all the different. If you look at the older blog posts that I put out, they a lot of them covered that stuff already. So there was a lot of like layer 2 specific stuff, preferential forwarding, and then the different failover techniques. So those have already been covered. I'm not going to recover something that I've already done, but I wanted to cover these in a bit more detail, so that, and to me, more thoroughly. I think the last time I did it, I was a CCNP level deep dive. This one's a little bit deeper. Again, I'm gonna, as I go through, this actually is helping me prepare for the rest of my CCNP service spreader content that I'm going to be putting out here soon. The route workbook is already done. I'm going to start on the SP, or the advanced route workbook here soon, probably after I get done with some of this other testing, and I'll go from there. But that's pretty much it, guys. I'm not going to sit here and go on for an hour like I have in a couple other videos, but that's pretty much it for option C. Again, if you want to see the configs, now I will caveat this, that I left a lot of the intra-AS VPN configuration out. So IGP and LDP not documented. VRF configuration not documented. Multi-protocol BGP and the individual SP cores not done. I went in and explicitly configured that, and then I copied and pasted out of the running config what is needed to get inter-AS VPN up and running. So the configs are specific to that. So if you are looking for intra-AS L3VPN base config, so IGP, LDP, multi-protocol BGP, VRFs, PE2CE routing, all that type of stuff, if you're looking to get those 4 things up and running, then there are older blog posts or older videos you can go watch that cover that. That'll get into those details, but that's pretty much it. We're going to be covering a lot of other techniques down the road, and stuff like that. But this is, I'm exactly 2 months, just a touch over 2 months out from the written. So I'm taking advantage of the time to go through this material. I don't have a lot left to cover on that. Once I'm done with layer 2 and layer 3 VPN, I want to go do some multicast and get that tested out some more thoroughly. I'm probably going to take this topology and run with multicast and see what my options are and test that out again, or take it a step further. The reason why is because the fact that after having talked to the CCIE SP program manager, it's been stated that profiles 0 through 9 for multicast VPN are not going to be the only profiles that they could potentially test you on. They could test you on all of them. So there are 27, I believe, 26. I believe it goes 0 through 26. So the bulk of them are only supported in XR, and the current version of XR that I'm using, and I will be getting, I'll be working with this in Viral. Once I get past the written exam, I'll spin a Viral back up and I'll start labbing in Viral, because that's going to be the platform I'm going to have to get accustomed to for the CCA lab. But that's the goal anyway. And as I get closer to that, then I'll spin Viral back up and get that operational. But as it sits right now, XR 6.0, iOS XR 6.0, the version of code, doesn't support multicast in the data plane. So I'll have to have 1 or 2 XR 5.3 boxes deployed to do the data plane version, because the last time I tested multicast VPN out, it was inside of 5.3 and it worked. 6.0 it does not. And that was only working for the ROSE and GRE model. So the MDT for the default MDT with GRE tunnels. That's the only one that's XR supported in the data plane. So I'm gonna test that out. I've only got a couple of XR boxes at the provider edge level in the first AS. So the bulk of the provider edge routers are iOS boxes, and that's been done on purpose, so that when it does come to multicast VPN, I'll be able to test that out. I'm probably going to add a couple more, just because of the fact that I want to have a lot of CE devices to test out with. But that's pretty much it, guys. More to come. Keep your eyeballs peeled, and I'll catch you guys later.